So, first test, who use Postgres? It's good. And who use PL pgSQL? Few arms. And who did some migration from Oracle? Okay, so maybe you are here well. And I think so it's a good time for start. No, 2 minutes, 2 minutes. 2 minutes will wait. So I can use free time, and somebody who use console PSQL in terminal. Nobody knows PSQL. Yeah. So I wrote the software that maybe you use. If you use PSQL, then it's good to know. So Linux is possible to set a pager on Linux, and default pager on Linux is more. And if you use console with default configuration, then it's not too much usable when you wrote a query to some wider table, like here. Class. Who knows? No, it's stupid. Yeah, I have PSQL pager. This. So default behave is like here. Who knows it? And when the result is like here, I'm not autist, so I cannot to work with this result. Sometimes I can decrease font, and if you decrease font, it's better, but still not. And still not. And yes, it's good. But I don't know, maybe for somebody else. When I was younger, I had a computer ZX Spectrum, and the one hair was from 4 pixels. So I was trained, but still, I need a little bit more comfort. But there is other pagers. Do you know other? What is second pager in Linux? Less. So you can use less. And what is important, the option S. And if you use this option and these settings, all is much better. So if you use MySQL, if you use Vertica, maybe Monet, all the clients that use pager, you have to know so you can increase your comfort with less and option S. But it's still not good, not too much good, because, for example, I can scroll to this position and I know nothing about where I am. And then I wrote better pager just for this case, not generally, PSPG. And when you run this query, you can scroll everywhere and you can see the contents every time. So this is PSPG. What is important and what is nice, for example, can you help me? I try to search the most big table on my database. How can I do it, this task? How I can find the bigger table on my database, current database? It can be calculated from a PG class. There is a rel pages column. But I show you another trick. When you run PSQL with option big A, and there is a nice command or backslash command, backslash DT S. I have nothing, so plus. Then you can see a lot of the sizes. But it is sorted in schema and name, and but the option E show the query. So I can take this query, push it again, run Vichko, and replace order by, there is a function pg table size. I can copy there, oh shit, pardon. Des sk dvojtečka x, what? Now. And I have sorted tables by size, and I don't need to search something in documentation. So it's good to know PSQL with big A. For example, if you search where is info about users, when is info about databases, run PSQL with big A and /du. It's show me info about users. Book. And here you have to look to table PG rules. And I don't need such documentation. Or I can use PSPG, and normally vertical cursor is hidden. So I can show vertical cursor, run to column, press D, and now I have table sorted. So this is PSPG. And now is good time for start the presentation. This is just few tricks for Postgres. So now I will speak about performance issues related to migration from Oracle. This issues is really similar to generic issues about performance. It's not big difference if you search issues typical Postgres application or application migrate after the migration from Oracle. It's very similar. So something about me, but it's not important. This is more important. So performance issue. When you migrate some application that was designed for Oracle or was worked on Oracle 10 years and maybe more, then performance issues are expected. A lot of time the people fixed issues on Oracle, and when you do migration to new database, Postgres, Microsoft SQL, MySQL, anything, then performance issues are expected. So you have to calculate with this. There is some benefit or some help. Usually we use modern hardware. We use modern version of Postgres. A lot of time you migrate from old version of Oracle and you migrate to modern version of Postgres. So this help to us, but performance issues are expected. Why there are performance issue? Because Postgres is not Oracle. Maybe some people say Postgres is cheap or gratis Oracle, but it's not true. Postgres is one database, Oracle is second database. And when you migrate some product between these databases, you have to expect so something will be different. What can be different? Storage, planner, optimizer, executor. What does storage? Storage store, save your data. Planner. What is task? What is task for planner, for example? Who knows what is planner in database? When you write a query, for example, select from table where, select from people where the name is Stehule, then it's not, you say what you want to see, but there is not, you doesn't specify what way is to get the data. And planner have to generate all possible variants, how to solve the query. Planner on Postgres is different than planner on Oracle. So this is one reason of differences. The optimizer, the task for optimizer is choose one variant of generated plan, and this plan will be executed. Executor on Postgres is different again. So there is a lot of differences. The reason for these differences is historical. The Postgres was a university and hobby project, and nobody calculated, so this project will be used like a replacement for Oracle. Oracle was a strictly commercial project with commercial target. And so back to storage. This is very common reason why some queries on Postgres are slow or less or more. It depends on the usage, on the context. Postgres and Oracle uses multi-generation architecture, multi-version concurrency control. Who knows what is MGA? So what is, do you know something, file system ZFS or BTRFS? The principle of multi-generation architecture is don't rewrite data when on update, but append. Postgres on update, don't rewrite data, just append. Oracle does the same things, but the implementation is different. The versions of row in Postgres stay in same table, same file. In Oracle, the historical versions are stored in undo log. And this implementation, this different implementation has impact on performance. Oracle implementation is more complicated, more technically complicated, and Postgres was a hobby project. So developers use more simple solution. Now this solution has different behave. Oracle has faster updates, but very slow rollback. Postgres has a very slow rollback. Rollback in Postgres needs 0 time. It's absolutely fast, but update is slower. And if you try update same line, same row, it's slower, slower, slower. And if your application try to do a lot of updates, repeated updates on same rows, then Postgres maybe is not good database for you. For example, MySQL can perform much better for this case. But this is not typical case for Postgres. For example, this case is typical when you use Postgres, when you use database like storage. If you say, I use database like storage to do Postgres developer, it will be very sad. Postgres is database, and lot of almost all operations in Postgres should be done on Postgres level. You don't use Postgres as storage. It's not optimized for this purpose. If you have an application that generates a lot of updates, it's possible. So on Postgres, these operations will be slower. Another issue related to this architecture, this issue is joint related to long transactions. Any database don't like long transactions, and Postgres don't like long transaction too. And usually nobody, it's not problem for people. But when you migrate application from Oracle to Postgres, then you can find some broken application. This is application issue. When application don't close transaction, and Postgres is much more sensitive on this situation than Oracle. I think so. Maybe you agree with me. So 1 week or 2 weeks open transaction is not good. And but on Oracle, this is not too big problem like on Postgres. So on Postgres, in Oracle too, close transaction when it's possible. And another issue related to storage is work with indexes. Postgres is much more sensitive on number of indexes than on Oracle. So if you have a table with a lot of indexes, then update on Postgres is significantly slower. And again, you have to reduce number of indexes, what is possible. Usually it is possible because developers likes indexes and put index on every column. But only on few columns indexes are used. So generally, you can reduce number of indexes very often, and it's not a problem. But remember, on Postgres, it's good to have only indexes that you use. Do you know somebody where I can detect what indexes are used and what not? But no, yeah, generally. Not per one query, generally. Postgres has a very nice table, pgstat user indexes. Select hvězdička from pgstat user indexes and all indexes for me. And then you can see name of index and number of usage, how much the index was used, how much rows returned. And from this table, you can easily detect what indexes are used and what no. And all indexes that was not related to primary key should be removed when it's possible. So pgstat user indexes is good table for you. Another issue, another source of issues, performance issue, is planner. Oracle planner is really complex and really rich, and try to fix a lot of situations, a lot of developer issues. It is related to commercial development. Oracle was used for migration of some older application, and in this application there was not possible to fix application. So Oracle had to do some fix on a database level. It is not possible in open source free project because this fixes, this optimization significantly increase the complexity of planner. And in Postgres is strategy. What can be fixed on application level, it should be fixed on application level. Oracle try to fix developer issues, Postgres not. So if developer write strange query with a lot of self-joins, a lot of useless joins, then Oracle does much more intensive cleaning than Postgres. And sure, the query on Oracle will be faster than on Postgres. So this is a really issue. But I have experience, well-written application can be migrated to Postgres very well. But second experience, I see well-written application, I don't see never a well-written application. So it's not easy. Another issue is related to functions. When you use function in where clause, then you have to know, so function is a black box for almost all databases. But some functions are recognized by databases. For example, Oracle and Microsoft SQL know the semantic of call-ask function. And but Postgres has not anything about function inside. So, for example, when you use select star from top, where call-ask call comma 0 is equal to 0, and then Oracle does a transformation to call is null or call is 0. But Postgres doesn't do this transformation. And sometimes you have to do this transformation by your hand. Sometimes when you got wrong estimation or when you got some slow queries. Postgres can use index on second query, but cannot to use index on first query. So sometimes you can increase the speed with index. Can you increase the speed, performance with better estimation when you change the function by native expressions? Another issue, optimizer. Optimizer is differently configured than on Postgres than on Oracle. Oracle optimizer is very rich, but is very slow. But it's not too much a big problem because Oracle use plan cache, and Postgres has not plan cache. So default configuration of PostgreSQL optimizer is different. Postgres optimizer is faster, but it's a little bit lazy. It doesn't do all necessary work. And if your query is really complex, if your query has more than 8 joins and 8 subqueries, then Postgres doesn't search real optimal plan. It returns something like optimal plan, but it should not be optimal plan. You can change this feature, this behave, by configuration. And I don't know how much people knows very important parameters from collapse limit, join collapse limit. Knows somebody these parameters? Yes, one boy. So this is very important because for more complex queries, if you want to better plan, you have to increase these variables. Usually there is problem with views. Views are typically very simple, but when I look to execution time for some views, it's a big creature. And for the big views, it's good to increase these values. But when you increase these values, the planning time will be bigger, the memory consumption will be bigger. So you have to find some compromise. Another issue can be another optimizer in Postgres. Do you know somebody about genetic optimization? There are two methods, more methods about optimizations, and one method is genetic, and Postgres has genetic optimizator, and this optimization is started when complexity of query is higher than some number. The number is GQ threshold. The genetic optimization is very fast, but don't ensure the optimal plan. You got some good plan, but cannot be optimal. It can find some local optimum. And again, you can increase GQ threshold, then you prefer deterministic optimization, but the optimization will be longer, but the plan will be better. You can increase the quality of plan by setting some variables. Now a lot of people, a lot of companies use SSD, and on SSD you can decrease random page cost. With this value, when you decrease this value, you increase the probability of using index. So if your data is well stored in RAM, or if you have SSD, then you can reduce this value typically to 2. Attention, it should be every time higher than sec page cost. If you do this 1-to-1, then there can be a lot of problems. Another problem is effective cache size. Now this effective cache size is default configuration is about 4 gigabytes. But if your if you have hardware servers with 100 gigabytes or maybe more, this value is too less. And this value, low number in this variable reduce the possibility to use bigger indexes. So if your tables are bigger, but you have indexes, and if you want to use index, maybe, and Postgres doesn't use index, maybe effective cache size is too low. And last value that has a significant impact on performance and quality of plan is workmem. Who knows workmem in Postgres? It's not good. This is a really significant value and significant value for configuration of Postgres. Postgres planner usually have more possibilities how to execute a query. And usually you can choose faster variant with much more memory consumption, or slower variant with without memory consumption. And if you have higher workmem, then Postgres can choose faster variants. If you have a low workmem, then Postgres use slower variants. And typical configuration is usually now, if I remember well, 10 megabytes. And it can be increased to 20, 200, and sometimes for OLAP queries, 2 gigabytes. So you can increase this value significantly more. It has impact on speed, joining, or grouping, sorting. So a lot of operation can be significantly faster. Default configuration of Postgres is very low, very safe to memory sources. And if you push more memory to Postgres, your query can be much faster. So I mentioned the possibility and the issues and sources of issues. And the base problem is, so Postgres is not Oracle and Oracle is not Postgres. And what you can do, so first you have to be creative. Postgres is open source and creativity is expected. And but there is a lot of tools, and there are a lot of people who can you help. For example, in Moscow is Postgres Pro, and Oleg Bartulov and other people who knows Postgres very well, and I'm sure so helps a lot of. And there is some mailing list with a lot of people who have experience about migrations. But so I will continue. So first you have to be creative. Okay. Second, it's not bad to run before any testing, any checking, any benchmarking, vacuum analyze. So what does vacuum? Why Postgres has vacuum command? It does some garbage checking. Postgres, I hope so I can, when you do update, Postgres does new version of row. And when you run vacuum, Postgres, hey start, Postgres skips these versions and going skip directly to this version. So reading will be much faster. And what does analyze? Why Postgres has analyze command? It's because you need column statistic. The optimizer have to know how much people with name Stehule is in table people, how much people with name Novak is in table people. And if you searching, if you solving some performance issue, it's good to do like first step vacuum analyze on a related tables on a related database. You cannot do something wrong. There are also more variants of vacuum statements. Uh, First, vacuum analyze. This is lazy vacuum. It just optimize the access to rows. Another variant of vacuum is vacuum full, and vacuum full reduce size of data file. This vacuum analyze doesn't reduce the size, and when you have full scan, you have to read all file, and you have to read a lot of garbage or a lot of white space. But if you run vacuum full, then the versions are copied to new file, and on this new file are created new indexes, and table is completely fresh. So sometimes is problem in white space inside table. Sometimes can be problem in ineffective quality of indexes. So if you run vacuum analyze, then your table, your database will be completely fresh, and it can help with performance. So next step have to be identification. What is slow? You have to detect slow query. You have to detect slow part inside your code. There are some tools. One, the most easy tool is logging slow queries. Postgres has good option, log min duration statement. If you run Google, Google knows everything. Log min duration statement. This is really important when I do some audit, some performance audit. I want to slow query report from my customers because I need to get some picture about application. And this is a really easy way how to get it. You set log min duration statement. Typical typical for desktop application is 100 or 200 milliseconds. For some analytic application is 5 seconds. For web shops is 50 milliseconds. It's not in when you want to optimize the queries under 10 milliseconds. It is not possible usually on the database level. You need some application cache. A lot of queries can be better, can be executed before, under 1 millisecond, but under high load, the queries about 1 millisecond has a big divergence. What can help indexes? Indexes are important, and I have here two forms of indexes. Usually people knows functional indexes. Functional indexes is indexes on the result of some function, and a lot of things you can fix with functional indexes. What people doesn't know too much is partial indexes. And when you have some asymmetry in your tables, you can use this information, and you can index just a smaller part of a table. You can use conditional index or partial index. It is first example. Index with clause where. And Postgres use this information like hint. When the same constraint will be in query, probably Postgres use in this index. So with partial index, you can strongly you can fix a lot of issues. I did it. Here is some tools, some other tools. PGStat user indexes I mentioned. Next, PGStat user tables. What is somebody knows PGStat user tables? Nobody? In this table, PGStat user tables, there is some interesting informations, because you can see there you can see there the information when the table was last time cleaned, last time analyzed. You can see how much rows was inserted, updated, deleted. So from table PGStat user tables or PGStat all tables, you can understand the activity of application on table level. Classic tool, explain select. When you get some slow queries, you have to understand why the query is slow, and the basic tool is explain. I show some explains here. I had this, no. So history. So here I have one question, and if I want to read execution plan, I write explain before query. Hold on. And now I have execution plan. The execution plan, the possibility to read execution plan is very important. Who can read it from you? Few people. It's really important. Everybody can use SQL database. It is designed. SQL databases are designed for policemen, so everybody can use it. But until you can read execution plan, and I will speak about self, you know only few information about query. The database is black box for you. When you can read execution plan, you can see how the query is executed. And from this point, your experience, your knowledge about the database will be increased. I used database maybe 5 years, like developer, and when in this time, this result was like China cars for me. But I remember we did a lot of work, absolutely useless. When we optimized some issues, we optimized issues that help us with microseconds, maybe milliseconds, but minutes was lost. And when I can read this query, I can see a lot of information. For example, from this query, from this plan, I can see so hash join is used, and hash join is most fast form of joining. So I can see, okay, this query will be probably good. You can run explain in another mode. You can run explain analyze. And now the Postgres at runtime information, and on the right side you can read the time of execution. There are two numbers, actual time, and first number is time when first row was computed. And second number is time when last row was computed. And it is in milliseconds. And you can see where was slow operations inside query execution. What you can see here, another information is possibility to compare estimated rows with real rows. On the first line, estimated rows was 11, and real is 63. And if the estimation is similar to real rows, then plan will be usually well. When the estimation will be significantly different, then the plan probably will not be good, and this is signal, so you can try to change something. The estimation is base, and when estimation is not good, almost all is wrong. Another interesting number here is planning time. Planning time should be low number, and I have experience when this number is high, maybe 10-20 milliseconds. It is signal but bloated indexes. The table can be bloated because it's not well vacuumed. Indexes can bloat too, and when index has suboptimal plan, then usually planning time is really big. Because in planning time, Postgres try to get minimum and maximum from index. This operation is very fast if index is good. But if index is not good, then taking minimum and maximum from index is slow. And you can see this on planning time. So if planning time is bigger, it's a signal something is wrong in the database. The execution plan, I return to previous example. This is set of operations. Any operation here is sort, hash, and sequential scan. Any operation read data from low and push data to up. So for example, hash join needs to read data from sequential scan and push data to sort. So execution plan is you have to read from top to down, and it's executed from top to down, and it means give me some data, and from down to top data is pushed. Execution plan is important when you want to ask about some help, because nobody understands to your query, nobody understands to your tables, nobody knows your context. But if you have execution plan, probably the people who can read it, can you say, maybe this table is strange, maybe you need index here. And if you want to ask somewhere, you have to push execution plan. There is an interesting application for sharing execution plan, explain the PGConf. This is application designed for sharing execution plans. I use it, example, and it can show me this colorful table. I don't use it. I don't know what this means. But I use this plan. This is original, and sometimes I use these statistics. I see what operations are slow. I see now it is sequential scan, and I see on which table it is. So this is not too much correct, but it's very easy to read it. So nice, simple application, explain the PGConf for sharing plan. And Postgres is a community project. So there is a lot of places where you can ask about quality, about plans, and but you have to push this information to other people. So there is some other tools. Maybe you use the extension pgstat statements. This is good extension for monitoring queries, query monitoring. When you install the extension pgstat statements, then Postgres will update the table pgstat statements, and you can see there how much times what query will be executed, how much what is median time, what is average time of execution. So it is very easy for using extensions. Log mean duration statement, I say about it. Another interesting extension is auto-explain. Sometimes you cannot repeat slow queries because something in your environment was changed. But if you use extension auto-explain, then Postgres log execution plan of slow query. So you can see why the query was slow. When you use log mean duration statement, then slow queries is logged to PostgreSQL log, and you need some tools for generate reports. There is good two tools. PGConf, this is very simple tool just for analyzing slow query, or pgBadger. This is very complex tool for complete processing of PostgreSQL log. So if you need some tools for monitoring, you can install PGConf or pgBadger. All tools are free. And sharing plan, explain the PGConf. And here is for the end. Here is one questions, and on these questions I can understand how much you know Postgres. I create table foo, and I run analyze on this table, and when I wrote explain how much rows will be expected from this query. Who expect 0?
У нас времени, к сожалению, очень мало осталось, поэтому давайте 3 вопроса.
So unfortunately, we don't have much time, so that's why we will proceed with the Q&A.
Who expects some other number? Nobody knows. I think so. The result will be probably about 2,000 rows. It's a little bit strange, but Postgres doesn't like empty tables. And expect so nobody has empty tables. So when you have empty tables, then Postgres say, no, it's something strange. Your table has 10 pages, and calculate number of rows from width of row of table. It's something is strange, and I have to write patch for one customer, and I have one customer who every time push one row to table to not be empty. And it's this is details, but it's life. A lot of details you have to know when you want to fix this issue, some performance issue. So remember, Postgres doesn't like empty tables. And here is some resume. So why is some queries are faster on Oracle and not on Postgres? Because there is different planner, there is different optimizer, and a lot of time the people has default configuration, and default configuration is designed really for small computers. So if your server, if your database server is not small, then you can increase these values. And that's all. My experience is so almost time the fixing of queries is not too much hard, but it needs some work and it needs some detection. You have to search query why it's that is slow, and you have to try to detect why. And the reasons is sometimes really different. It's not repeated. Sometimes I can say, yes, there is wrong estimation, there is nested loop, and it's clean why the query is slow. But sometimes, like with empty tables, I have to read a lot of papers. Maybe I have to read source code to know this information. So please use Postgres well. As from my side, finish. And queries? Please query, if somebody has. Somebody has some query? No? Yeah, I'm sorry.
Теперь точно мой выход.
Now it's definitely my time to shine. I think they will translate it. Hello, I've got the following question. You said that in Oracle the plan is being cached, and in Postgres it's not cached the way I understand it.
Somebody translate me to English? It's no problem, somebody knows English. So, please, try to simple English if you can. Yeah, yeah.
Postgres not use cache. Please.
Cache. Oh, hash. Cache.
Переведите, пожалуйста. То есть вопрос в том, что Oracle использует?
Oracle is using caching of the query plans, and Postgres, the way I understand it, doesn't cache the query plan. And then there was a slide on how to optimize it, where we could change certain settings, we could increase them. Could it lead to that if the queries are happening too often, then Postgres is going to, with increased settings, is going to plan longer and it will lead to problems?
So if I understand the questions, the Postgres has not plan cache like Oracle. So it is good and it's both, but with plan cache on Oracle there is a lot of problems too. And because Postgres has not plan cache, a lot of problems are not in Postgres. But sometimes when your queries is too big, then the planning time is really big, and if you run this query again, then it's a problem. What you can do, you can use prepared statements. In Postgres is command prepare. I show simple example. Prepare x as select and now I stored prepared plan, execution plan under the name X. And when I use command execute, then this plan was executed. So what Oracle does implicitly, I can do on Postgres explicitly. There is some risk or there is some issues because the plan is stored when you use when you repeatedly use some plan, then it's possible to use plan for different parameters than was optimized. And Oracle has some strategies, and sometimes Oracle can invalidate this plan from plan cache. Postgres don't do this, and there is some heuristic. When you run execute statement first 5 times, then Postgres collects some info about execution, and after 5 times execution, Postgres switch, do some decision, and mostly time repeat the prepared statement again. For example, for insert statement, for update statement, and for other statements, it generates plan every time. So you use use execute against the prepared plan, but Postgres prepared the plan for any execution. So it can fix some issues, but it's true. So with prepared plans, there are a lot of performance issue, and it's not easily fixed. It's hard to detect because it's a little bit strange. When you run some query, first 5 times, it's fast. When you run this same query in 6th time, it's slower, and nobody knows why. So it can be reasoned because the plan is reused, and is reused for different vector of parameters than for what was optimized. It's a very complex issue, and I don't think so it can be fixed yearly or every time. So it's a technology limit. So I hope maybe it is my question. My reply was good, or no good was to your questions. Okay, thank you. So another question.
Могу ли я добавить?
Can I add to what was said? The thing is that we faced this problem before. We had this issue before. The first 5 times Postgres is creating a plan using certain parameters, and after that it's building a plan without the parameters. So inside the plan you will be able to see the parameters that it's using. So if the query depends a lot on parameters, then the plan will be really inefficient. And factually, we are calling queries using Java, and we had to set Java to disable the use of this prepare because it killed the performance. It just brought it down to 0.
Java use prepared statement, and but the prepared statement is hidden because you use some Java API, but the problem is same. And it cannot be fixed. No, it can be fixed if you have Postgres 12. There is possibility to enforce planning, replanning every time. So you can switch, you can change the configuration for some databases, for some users to replanning, force replanning every time, and you spend sometimes on inside planner, but Postgres planner by default is significantly faster than Oracle planner. And you can fix the issue with wrong plans. Okay.
Еще есть вопросы?
Any other questions? Is this it? Do you want to ask a question? No? Well, okay, then let's applaud to our speaker. Thank you very much.